Hello guys, this is Algebra 2 online and this is your teacher, Mrs. Belyakov. Today's lesson is solving abstract equations. The purpose of this lesson is to use inverse operations to isolate a variable. So at the end, we're not going to have like a number as a result, but another equation. So let's see, I'm just going to explain 3 examples of this lesson which are on your book of Algebra 2 in Saxon. So let's see example number 1. It says, solve for c, and they're giving us the equation f equals 9 over 5c plus 32. The idea is to isolate the c. So I'm going to start moving the terms that do not have the c. When I say move, I mean use the inverse operations to isolate the variable they're requesting us to. So I'm going to begin by eliminating the 32. Remember, opposite operation of addition is subtraction. So I'm going to move it to the other side of the equation, subtracting. So now we have f minus 32 equals 9 over 5 times c. Now I need to get rid of 9 over 5 times c. Remember, how do we get rid of a fraction that is multiplying a variable? That's correct. We use reciprocal. So I'm going to move it to the other side of the equation in reciprocal. Remember that if you have, for example, 9 over 5 times 5 over 9, we cancel and the result would be 1. Every time you multiply a fraction times its reciprocal, the result is 1. So let's do it. The reciprocal of 9 over 5 would be 5 over 9. And then times, since 5 over 9 has to multiply all of the terms on the other side of the equation, we're going to use a parenthesis for that. F minus 32, close parenthesis, equals c. Since the letter c is now isolated, and that's what they're asking for, we're done. Let's see example 3 now. 2, sorry. It says solve for h. Where is h? All the way here. We need to isolate that variable. So the equation says s equal 2 times pi times r to the second power plus 2 times pi times r times h. Why did I make the pause here? Because every time you see a plus or a minus symbol, it means you have different terms. So this is a term and this is another term. I'm going to get rid of the term that does not have h. I'm going to leave this one to the very end. So I'm going to move this term to the other side of the equation using always the inverse operations. So let's see how it works. This term, even though you don't see the sign, is positive. So it goes to the other side of the equation using the subtraction. So s minus 2 times pi times r to the second power equals the last term, 2 times pi times r times h. We're almost done, because since 2 pi and r are multiplying the h, I can use all of this in the inverse operation and bring it to the other side of the equation. All of these terms are multiplying h, so I'm going to bring them to the other side of the equation, dividing. So s minus 2 pi r to the second power, all of that divided by 2 pi r equals h. Since h is already isolated and that was the purpose of the example, we're done. Third and last example, it says solve for h. Again, because we were isolating h in the previous example. So let's see, where is h? Oh my God, it's here. Let's see, L equals pi times r times the square root of r to the second power plus h to the second power. So I'm going to begin getting rid of the factors that are outside of the root, multiplying it. pi times r is multiplying the entire root. So I'm going to use pi times r, which are multiplying, and I'm going to bring them to the other side of the equation, dividing. So L divided by pi times r equals the square root of r to the second power plus h to the second power. Okay, we're getting there. Now, r and h are inside of a root. I have to get rid of the root first before getting rid of r, or this second power. Opposite operation of a root, that's right, is an exponent. So I'm going to bring it to the other side as an exponent, because that's the inverse operation of the root. Pi r, all of that to the second power, which equals what we had inside of the root, r to the second power plus h to the second power. Let's read the statement of the example so we can remember what we're doing. Okay, solving for h. That means that between r and h, we're isolating this variable. That means r goes to the other side of the equation using inverse operation. R is positive, so I'm going to bring it to the other side of the equation, subtracting. Let's see, L over pi r, all of that to the second power, minus r to the second power, and that equals h to the second power. Okay, we're almost there. Why do I say almost? Because even though h is alone by itself on that side of the equal symbol, we have an exponent. And for the h to be isolated, we cannot have root nor exponents. So let's continue on this side. What is the opposite, the inverse operation of the exponent? Yes, that's right. It would be the square root. So I'm going to put everything inside of a square root. I'm going to put everything inside of the square root to get rid of this square. So let's see. What did we have inside? We have L over pi times r minus r to the second power. That equals h. All I did was to move this exponent to the other side of the equation as a square root. Let's see how it looks. Okay, h is already isolated. Since that was the purpose of the example, then we're done. And finally, let's read some Bible integration. It says, "Thanks God because letters and situations may vary, but He remains immutable. He never changes." Well, that was all, guys. Now, let's read the assignment, or I'm gonna let you read the assignment for this lesson, which is usually the lesson practice. If you have any questions, please let me know in the comments. Love you.